Hey guys, let's try this problem right here. Here this question is asking to evaluate this integral. To find this one, what we can do is, if you notice, this is a 9 minus x square, and this is number square minus x square pattern, right? So we have three pattern to do trigonometric substitution. This comes as one of the pattern. So whenever we have number square minus x square, we use x is equal to a sine theta, right? So this is what we can substitute. Now a is what? This here we have 3 square minus x square. So instead of x we can substitute 3 sine theta, right? Now let's go ahead and substitute. So here we are going to have square root of 9 minus 3 sine theta, and if I square that one, that's going to give us 9 sine square theta, right? So this is 3 sine theta. Now we have to replace something with dx, right? So if I find the dx for this one, this is going to give us 3 cos theta. Derivative of sine theta is cos theta d theta. So we can now replace this dx with 3 cos theta d theta. And in the bottom we have x square, that's going to be square of this one. That's going to be 9 sine square theta d theta. Now whenever we have this kind of problems, whenever we have this trigonometric substitution, the first thing we should try to do is we should try to get rid of this square root, right? How can we do that? If you notice, we can take the 9 common, so that way we can eliminate 9 out. We can take 9 out of this square root. Let's do that one first. So if I take 9 common, this is going to be 1 minus sine square theta, right? Sine square theta times 3 cos theta d theta. And then in the denominator we have 9 sine square theta d theta. Now we can take the 9 out of this square root, that's going to give us 3. And also if you notice, 1 minus sine square theta. We know that cos square theta plus sine square theta is equal to 1. So 1 minus sine square theta is equal to cos square theta. So we can replace this one with cos square theta. That way we can get rid of this one also out of this square root. Now outside we have 3 cos theta d theta, and in the bottom we have 9 sine square theta d theta. Now we have 9, and on top we have 3 times 3. So these two are 9, right? 3 times 3 9. So we can cancel these two with this one. Now let's get rid of this square root. So this is going to give us integral cos theta over, there's no d theta right here, and this should be sine square theta, right? Okay, now let's cos theta, and also we have another cos theta d theta over sine square theta. Now let's see what we can do from this moment. So we have 2 cos theta. Let's combine them together. So this is going to be integral cos square theta d theta over sine square theta, right? In this way we cannot do anything. So what we can do is we can take cos square theta as 1 minus sine square theta, as we did before. We know that cos square theta plus sine square theta is equal to 1, right? Equal to 1. So from that one we can derive that cos square theta is 1 minus sine square theta. So we can replace this cos square theta with 1 minus sine square theta over sine square theta d theta. Now what we can do is we can write this one as 2 different integrals, like integral 1 over sine square theta d theta minus integral sine square theta over sine square theta d theta. So this way it is easy to integrate. Now 1 over sine square theta is cosec square theta, so this is going to be cosec square theta d theta, and sine square theta over sine square theta just 1, right? So that's going to be just d theta. Now let's integrate. So if I integrate this one, what's going to happen? We know that derivative of tan square theta is sec square theta. Derivative of cot square theta is minus cosec square theta. So integral of cosec square theta is going to be minus tan theta, right? I mean minus cot theta, because tan sec square theta, cot minus cosec square. So integral of cosec square is going to give us minus cot theta. So this integral is going to give us minus cot theta, and that's it for this one. That's it, and we have d theta remaining, and if you integrate d theta, that's going to be just theta. So theta, and also we are going to have constant in front, right? Constant. Now all we have to do is bring it back to x pattern, because our original question was in x pattern, so we have to bring this back into x pattern. Now to do this one, what do we do is we bring this one. Initially we took this one, right? We took x as 3 sine theta. So if x is equal to 3 sine theta, we know that sine theta is going to be what? X over 3. And we know that sine theta is opposite of hypotenuse. And if you draw a triangle, and let's put right angle triangle, and if you put a theta right here, we know that sine theta is opposite of hypotenuse. So opposite is going to be x, and hypotenuse is going to be 3, right? And if you use the Pythagorean theorem, and we know that Pythagorean theorem is hypotenuse square is equal to addition of both sides, right? Both sides squares. So here we have hypotenuse. We have to find this one. So if you subtract square of this one from hypotenuse, that's going to give us this one. So square root of 9 minus x square is going to give you adjacent, right? Now we have the adjacent, and we know that cot theta is reciprocal of tan theta. Tan theta is what? Opposite over adjacent. So cot theta is going to be what? Adjacent over opposite, right? So this is going to be, now let's continue this one right here. Minus adjacent over opposite. Now adjacent is 9 minus x square. So square root of 9 minus x square. And then opposite is what? X. So we are going to have x right here. And replacing theta is easy. All we have to do is take the inverse, like sine inverse x over 3. So this is going to be sine inverse x over 3 plus constant, right? That's going to be our final answer. I hope this helps. Thanks for watching.